Today, we're diving into an exciting project, a voice-controlled music player using Python. Here is a quick preview. Play.
Our hearts beat to the city streets. We began to feel the fire. We rise like...
Resume.
Tall buildings, as the chemicals they take us higher.
This music player will not only play songs but also respond to voice commands like play, pause, resume, and stop. You will learn how to handle the PyGame Mixer, implement speech recognition, create separate threads, create a very cool progress bar as well as to catch errors in your code. And as usual, for those who stick around until the very end, I have one cool extra feature for you. With that said, let's dive right in. First things first, let's make sure we have all the required libraries installed. Open your terminal or command prompt and run these commands. Pip install Pygame. Pip install speech recognition. Pip install PyAudio. Now, let's import the necessary modules. Pygame module for the game framework. Speech recognition module for recognizing voice commands. The threading module for handling voice commands in a separate thread. The time module for keeping track of certain points in time. The OS module for interacting with the operating system when handling the MP3 file. Next, we initialize the PyGame Mixer module. By doing this, we're setting up the sound system that will allow us to load and play music files. We also initialize the Pygame GUI for the user interface. And define the dimensions of the window. This gives us a simple window where we can display the current song and playback status. Also, don't forget to set the caption. Next, we define the fonts and colors for our GUI elements. This makes our display more user-friendly and visually appealing. We define some colors for the background, text, and progress bar. We'll need some global variables to hold the current state of our music player, such as the song title, singer, playback status, and timings. What are global variables? Global variables are variables that are declared outside of any function, and they can be accessed and modified from any part of the code. This is different from local variables, which are declared inside a function and can only be used within that function. In our music player, we use global variables to keep track of what's happening, for example which song is playing and if the status is playing or paused. This way, these variables can be accessed from any function in the code. Set initial values to all our global variables here. An empty string for string variables and 0 for integer variables. We set the boolean running to true to start the music player at the beginning when we first run the Python script. Now, let's write the functions to control the music, play, pause, resume, and stop. These functions will use pygame.mixer.music to control how the music is played. We start with the play music function. This function takes the path to the music file as input. First, we define the global variables that we will use in this function. We use the PyGame Mixer to load and play the music file. We also assign values to the start time of the song and the song length for creating the progress bar later. For this project, the music file name is in the format song title, singer. Knowing this, we can extract the song title and singer from the file name in this way. Question: what should we enter here to remove the .mp3 extension from the file name? That's right, we replace it with an empty string. The split function in the second line splits the file name at the dash. We update the status and also print a status message in the terminal. Next, we have the pause music function, which is very straightforward. Simply pause the music and update the status. We also create a resume music function. In this function, we want to make sure that when we resume the music after pausing it, it starts playing from where it was paused. To do this, we need to keep track of when the music started playing originally. The start time is recorded when the song begins, and the elapsed time is tracked to determine how long the song has played. We will use the elapsed time later to create the song progress bar. To refer to the current position in time when we resume the music, we assign the new start time to the current time minus how long the song had played earlier. This ensures that when we resume the music, it starts playing from the correct position. In code, we use the time.time function to get the current time. We also use pygame.mixer.music.get_pos to get the position of the music when it was paused. Then, we subtract this position from the current time to calculate the new start time. This ensures that when we resume the music, it starts playing from the correct position. Next, we have the function for stopping the music. Also pretty straightforward. Use the mixer music stop function and then reset all relevant state variables. We need a function to retrieve a song from a specified directory. For simplicity, we make the function return the first .mp3 file it finds in a folder called music located in the same directory as this Python file. We use list comprehension to get all songs in the music folder that has the mp3 file format. Then if songs is not empty, return the path of the first song in the music folder. To get the first song, what do we enter here? That's right, index 0. Now we create a function responsible for listening to voice commands using the microphone. It takes two parameters, recognizer, which is an instance of a speech recognizer, and microphone, which represents the microphone device. Inside the function, start listening for commands using the microphone as the source and print a message. Use the speech recognizer to listen to the audio from the microphone, with a timeout of 3 seconds for listening and a phrase time limit of 2 seconds. The timeout refers to the maximum amount of time the program will wait for audio input from the user, while the phrase time limit refers to the maximum duration of a single phrase that the program will attempt to recognize. Next, we will use a try-catch statement. In programming, a try-catch statement is a way to handle errors or exceptions that may occur while running a piece of code. It's like having a safety net to catch problems that might otherwise cause the program to crash. The two components are the try block and the except block. The try block is where you place the code that you want to monitor for errors. This is the part of the code that you want to execute, but you're not sure if it will run successfully because it might encounter some problems. The except block is where you handle any errors or exceptions that occur within the try block. If an error occurs in the try block, the program jumps to the except block to deal with it. Here you can specify what actions to take when a specific type of error occurs, or you can provide a general error message for any type of error. So, attempt to recognize the audio and convert it to text using the Google Speech Recognition API. If the audio is recognized successfully, it prints the recognized command and returns it in lowercase. If the audio cannot be recognized, handle the unknown value error by printing a message indicating that the audio could not be understood and returns none. Now create a function to handle the voice commands received from the user with the same parameters as the recognize_voice_command function. Access the global variable running, which indicates whether the program is running. Create a loop that continuously listens for voice commands while the program is running. Listen for a command using the recognize_voice_command function. If a command is recognized, check the command for keywords such as play, pause, resume, stop, or exit. Depending on the command, it performs corresponding actions such as playing music, pausing music, resuming music playback, stopping music by calling the function we defined previously. Lastly, if the user has said the word exit, we set the variable running to false to break the loop. In this try-catch statement, we handle exceptions such as wait timeout error and request error. Next, we create a function called draw_progress_bar that is responsible for rendering a progress bar on the screen. As usual, start by accessing the required global variables. Then, check the current status of the music player. If the status is playing, calculate the elapsed time since the start of the song and compute the progress of the song as a fraction of the total song length. To compute the elapsed time, what should we subtract from the current time here? That's right, the time at which the song started playing. The progress value is limited to a maximum of 1.0, or 100%, to ensure that the progress bar does not exceed the width of the screen. If the song length is 0, indicating an invalid or unknown length, the progress is set to 0. If the current status is not playing, which could mean the music is paused or stopped, the progress is set to 0. However, if the status is paused, it maintains the previous progress value. This ensures that the progress bar remains in its last position when the music is paused. Finally, draw the progress bar on the surface using 3 Pygame.draw functions. Next, we have the update_GUI function, responsible for updating the graphical user interface (GUI) of our music player. Set the background color of the screen to black. Write the title of the current song and the name of the singer on the screen, using the specified fonts and colors, and copy the text onto the screen using the blip method. Draw the progress bar on the screen by calling the draw_progress_bar function. Use the flip method to update the display window with everything that has been drawn since the last flip. Think of it like painting on a canvas. You finish your painting, but it's not visible until you unveil it by flipping it over. Similarly, in Pygame, you draw everything you want to display, and then you flip it to make it visible to the user. Initialize the speech recognizer and microphone for voice commands. Run the voice command handler in a separate thread to listen for voice commands while the GUI is running. Threading allows you to run multiple tasks simultaneously within a program. Finally, enter the main loop for the GUI, continuously listening for events and updating the GUI accordingly. Now when we hit run, this window should pop up. Also, if you look down here in the terminal, you will see status messages. Let's try it. Play.
Our hearts beat to the city streets. We began to feel the
Pause.
fire.
Resume.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun.
Stop. When we now say play, again it starts over.
Our hearts beat to the city streets. We began to feel the fire.
Exit. Okay, now it is time for the bonus feature to make our music player extra fancy. Just add these lines right here under the progress bar, and you will have yourself a symbol indicating the status of the music. Pretty cool if you ask me. Play.
Our hearts beat to the city streets. We began to feel the fire.
Congratulations on completing this project. If you want to deepen your knowledge further, why not challenge yourself with building the cool rock, paper, scissors game in the link here. Also, don't forget to like and subscribe for more tutorials and comment your thoughts below. See you next time. Until then, I wish you all some bug-free coding.